The lack of input validation is the primary cause of many attacks on the web, including SQL injection, cross-site scripting, and other attacks. The root of this problem is in products not validating or incorrectly validating input that affects the users of the application. Improper input validation is used by attackers to bypass security measures such as authentication and authorization controls. It is also used to inject malicious code into the web application, which can then be executed by the server or client. On your screen right now, you are seeing a prime example of improper input validation. We pass user input straight into the database, and once that's done, we return the provided value to the user as well. In other words, we open our application to two types of attacks: SQL injection and cross-site scripting. From there, depending on the architecture of our product, both of those attacks can take different forms. SQL injection can be blind, classic, or out of band, and cross-site scripting can be either reflected, stored, or DOM-based. Having knowledge of the code behind the application, an attacker can now mount one or both of those attacks against it and steal it in a database, steal session cookies and impersonate a user, or do other things. Neither of those outcomes don't mean anything good for your database and your application, and validating user input will be our first step to a more secure feature. Here's how to do it. First, consider the use case of your application. The use case of your application will steer you in a direction that makes you understand what kind of attacks it may be susceptible to. Then validate user input by using functions built into your programming language, writing custom code, or by using software that does it for you. Here are a couple of examples. You can validate email addresses or URLs by using functions like filter_var. Filter validate email will ensure that the email is indeed an email, and filter validate URL will ensure that a link is indeed a URL. There are other filters. SQL injection can be mitigated by using prepared statements or PHP data objects, since they will ensure that user input does not get passed into a database query. Cross-site scripting can be mitigated by either not making user input visible or wrapping it in functions like HTML special chars or HTML entities. To perform a regular expression check, one can use preg_match. To replace portions of an input string based on a regular expression, one can use preg_replace. Finally, to return the length of the string, use strlen. Then act on it and build a validation function or two. So to recap, input validation can be done by using input validation functions we have just discussed, functions you build yourself based on your use case, using firewalls to detect and block malicious input, and also common sense. All of those things should make your application and database more secure. Subscribing to channels like this one is also a good idea. That way you'll be able to watch videos and improve the security posture of your application even further. I hope you've enjoyed this video and found it useful and entertaining, and until next time.